Hello, I'm HMV News Deputy Editor Neil Marriott, and I would like to welcome you to the latest HMV News Future of HVAC Podcast. Following on from our summit earlier this month, handily entitled The Future of HVAC, I'm joined by one of our key panellists, Dr. Matthew Truella, Managing Director of Kensa Contracting. He's going to talk about heat pumps and the challenges posed by a need for national decarbonisation of our homes. Dr. Truella argues that heat pumps will be a vital component to realising the government's stated commitment to end fossil fuel heating homes within just 6 years. However, despite this political interest in expanding heat pump use, consumer adoption remains relatively small. From a broad perspective, I asked Dr. Truella on how the industry, and more specifically Kensa's commitment to exclusively produce ground source heat pumps, can realise heat pumps' potential as a means to end a reliance on fossil fuel heating.
Yeah, I had thought to open with a little bit of a roundup for where we are, but actually Mike Childs from Friends of the Earth did it far more eloquently than anybody at the HMV News Heat Summit last week. His view, representing the Friends of the Earth, was that heat pumps are going to play a major role in the future, but at the moment he described the current deployment levels as pitiful. And I think he's probably got it about right. We think we're doing quite well. We're growing year on year. We're starting to do what we would consider large-scale rollouts of many hundreds of heat pumps rather than ones and twos here and there. But still, compared to the heating industry as a whole, we are still an absolute tiny scratch on the surface. To put some numbers on that, the total deployment of heat pumps in the UK each year is around 20,000 units, and that's air source and ground source, and compared to 1.6 million gas boilers per year, you can see that we're making very, very small inroads into that market. Yeah. Coming on to the future, there's calls from various parts of the low carbon agenda. Committee on Climate Change are calling for around 3 million heat pumps to be deployed by 2030. Doing the numbers back, that translates to around 300,000 per year. So you can see there's going to be a huge scale-up needed from the current 20,000 a year to 300,000 a year if we're going to get anywhere near our carbon targets or anywhere near the ambition of the UK government on renewable heat. So yeah, it's a huge challenge ahead of us. At Kensa, we feel it's important to make the distinction between ground source heat pumps and air source heat pumps. They're very often lumped together as an amorphous mass when people are talking about them, and we get why. That they have got a lot of similarities. They're both electrically powered, they both have heat exchangers, compressors and expansion valves, but actually the source of the energy, the ultimate source, really does matter. And at Kensa we've resisted the temptation to boost our sales and turnover by manufacturing and selling air source heat pumps, and chosen to stick 100% to ground source. That's where we see the future, and that's where we see the biggest potential for whole-scale decarbonisation. I don't know if you want me to go through some of the reasons for that, why we think that is. Yeah, like I said, inside the box there's a lot of similarities, but getting your heat from the ground is a much more stable temperature, so it stays the same temperature year round. So it could be -5 outside, it's still going to be between +5 and 10 degrees in the ground, so you still can get a good source of energy from that. The huge advantage that a ground source heat pump has is that it's the expensive bit, that the machinery you buy sits in your house, and it's nice and warm and protected, typically either in an airing cupboard or a utility room, sometimes a garage, but it's indoors. And if you've got a piece of kit that you quite like and you want to last a long time, keeping it indoors is generally a better idea than keeping it outdoors. An air source heat pump, by its very nature, has to access the air. That's where it's getting its energy from ultimately, and therefore it has to be outside, and there's no real way around that one. So from a lifetime point of view, it's you can typically expect somewhere between 50% and double the lifetime of a ground source heat pump as a unit itself compared to air source.
Dr. Truella accepted that efforts to try and build market demand for greater adoption of ground source heat pumps did pose some unique challenges for the sector, with price, unsurprisingly, being a major consideration.
The Achilles heel of the ground source obviously is the is the cost of putting the ground array in, sometimes the disruption involved. There is a slight trend within the market of fear of putting ground source in being worse than the reality. It's most of our clients, when we talk about doing a ground source heat pump program, are really worried about how we're going to manage the drilling, how that's going to disrupt the residents, how it's going to be noisy, messy, how that's all going to be worked. And there are challenges in that, and you have to plan that work properly. But actually, it's far more disruptive when you come into somebody's house and change their heating system than it ever is drilling a hole outside in the street. So most of our internal planning work actually is directed around the internal works, not necessarily around the ground source. So we certainly spend a lot more time on working out exactly how long we're going to be in someone's house, what shoes they're going to wear and how they're going to protect the carpets. That sort of thing we put a lot more time and effort into than the gardens. Typically a borehole takes 1 to 2 days to drill, and when you share boreholes between properties, you can have anything between 2 and 6 properties sharing the same borehole. So if you picture a street of properties, now you'll have a borehole every third garden maybe, and it only takes 1 to 2 days. You can see you can move down the street extremely quickly with a drill rig, so you get a very small amount of disruption for a couple of days, and then you're very quickly back into just reinstatement and the place looking normal again. Whereas when you go inside someone's home, obviously you have to be mindful of all their ornaments and their carpets and everything else inside. Plus, we typically don't decant people; they stay living in their home as well while the work's going on. So,
and all that, and it's good to get to still that unit who's still got the heating unit in the home.
You still have that heating unit in the home, exactly. Yeah. We think ground source heat pump has a better future. That the expensive bit that we spend money and effort putting into the ground is quite often a borehole, particularly when you're talking on a larger scales, and that could cost something like £4,000 to £6,000 per property. But the thing to remember in it is that borehole is there for over 100 years then, so that's actually only £40 to £60 per year of its working life. So it's a lot to ask for somebody to buy 100 years worth of energy out of the ground up front. But it is a good investment, and it does make sense over the long term. So
pushing it is the long-term investment?
Very much the long-term investment.
With a ban on fossil fuel heating in new housing set to come into force in 2025, the expectation is that solutions such as heat pumps, which can be powered potentially via renewable energy sources, will become a much more prominent solution for use. But with outstanding challenges to overcome around insulation, training and cost factors, I asked Dr. Truella how he expected the market for air and ground source products to realistically change and evolve over the next 6 years.
There's a few aspects that need to be addressed. That is the perception of heat pumps, the cost of different fuels, and the role that regulation has to play. So I kind of spend a little bit of time on those. The perception of heat pumps, quite a few people have heard about them now. It's starting to become mainstream to talk about heat pumps. It's obviously, given the numbers, it's still not totally mainstream to install them yet, but it's definitely mainstream to talk about them. And the awareness is rising, but there still isn't a huge amount of people that have that direct experience of living with heat pumps that they can tell their friends about. So it makes sense to move the low carbon agenda forward in the areas where it's easiest first, and those areas are anything that doesn't have access to mains gas right now and new build property.
Another important factor in market development identified by Dr. Truella was the recently unveiled proposals for a future home standard that he said would lead to much greater need for heat pumps in new builds. Ideally, this would need to happen well ahead of 2025 to prevent a sudden mass demand for the technology that could be difficult to meet. The future home standard is also expected to drive a slowdown of reliance on the current mains gas network.
It's now economically difficult to make a sensible argument to extend the gas grid to put new homes and new boilers and new heating systems connected to it, when we know in 15 years that we're probably likely to have an alternative to those. Yeah. The alternative in new build, the difference in cost extra is much, much smaller than it is in retrofit. So that's definitely the place to start. That will have an effect of growing the industry and the skills, but it will also have a huge effect on the number of people experiencing living with the technologies. And that will help change the perception almost in one policy decision. Yeah. You push that forward in new build.
So there's a sort of consumer awareness.
We'll automatically, if we move from 20,000, 30,000, 50,000 up to 100,000 heat pumps going in, bear in mind that there's around 200,000 new properties being created each year. You could go a long way towards the sort of numbers that the Committee on Climate Change are recommending the UK install between now and 2030, just with new build, and that will increase the customer perception out there. So that's one huge benefit that can come forward.
Certainly. I mean, I was going to ask, in extension of that, the barriers that we're sort of seeing at the moment. Obviously, the perception's one of them there, but in terms of policy-wise as well, things like RHI, you were mentioning the long-term investments. There was an interesting point raised about RHI at the summit, and that there's the danger of, if not already, being a sort of middle-class subsidy rather than actually the issues of fuel poverty and really transforming properties there. Is that in kind of one of the barriers, in a sense, in terms of the support of policy there to try and support sort of ground?
Yeah, I wouldn't necessarily 100% agree that the RHI has been a middle-class subsidy. It has been in certain circumstances, and definitely if you're thinking of a consumer buying a heat pump, that has been the preserve of the middle class. At Kensa, we've taken a little bit of a different view to it, so the vast majority of our work has been in social housing, and the RHI has made that possible. So the social landlord essentially invests quite a large amount of money on the upfront infrastructure and putting the systems in, and they earn that back over 20 years through the RHI, because that's a non-domestic scheme. That has worked well, and I've been in dozens and dozens and dozens of social properties where saving £20 a week on their fuel bill has made a huge difference to their lives. People quite often on just over £100 a week, saving £20 of that is absolutely vast. So we've kind of used the RHI as a tool for decarbonisation, but also with a fuel poverty agenda. I think we'd like to see more of that going ahead. I think that's having the social value alongside the decarbonisation agenda is important. It's important to everyone at Kensa, and I think that's the right way for policy to move forward. I think we will need subsidy. There is a route towards subsidy-free heat pumps, but it's going to take a while, and it's specifically going to take a while to bridge the gap between April 2021, when the RHI is due to finish, and 2025, when gas boilers essentially are likely to be banned in new build. There's certainly going to need some subsidy in that area, and then there is likely to need some sort of subsidy on to 2035 when we start to decarbonise the gas grid itself. So I think it's unlikely to move to subsidy free in the very short term. But alongside that, actually, the industry itself, it does need to come up with some better business models. We need to find institutions willing to invest on 100-year timescales and build out the ground source infrastructure, if you like, in the same way as the national gas grid was built in the first place. That's definitely something that needs to happen alongside the policy.
So alongside that, the subsidy, there's actually you have the business models, the sort of finance models there to make that, being able to realise it, I guess, is an audience.
And we've worked hard in our social landlord work to move away from the 7-year domestic RHI subsidy to the 20-year. That was a reasonably big leap. So we now have to put it out to 100-year really in our thinking. And as soon as you model on those sort of timescales, ground source really looks like a very sensible thing compared to pretty much any other kind of heating. If you look at it for the price of it on day one after it's installed, it looks quite expensive, but as soon as you put it on a 100-year timescale, it looks really cheap.
Building on his presentation at the Future of HVAC Summit, Dr. Truella discussed the challenge of increased power generation that would be required to support the electrification of heat. However, he said the issue had been complicated by outdated 2014 analysis. This suggested that peak energy demand for heating in the UK, particularly for all domestic properties connected to the gas grid, was around 7 times more than the UK's electricity generation capability at that time. Dr. Truella said that predictions from these findings that the UK would need to create 7 times the amount of power stations and wind turbines in operation were no longer thought to be accurate.
A few things have happened since that was published. Firstly, in 2018, the study was redone by different authors with 100 times more properties and a little bit more sophisticated model. They came to the conclusion that it's actually 4 times the current electricity peak, not 7 times. So again, that's starting to think a little bit more manageable. When you factor in the efficiency of heat pump, which depending on the flavour of heat pump and what heat emitters you have in the property, is going to give you anything between 2.5 and 4.5 times the amount of heat for the amount of electricity you use. So therefore the amount of extra generation you need to build in is only the same as we have now. So that's starting to look a lot more manageable. Then when you factor into the grid balancing that we were talking about earlier, with the shifting load from the peaks in the afternoon through to overnight and even mid-morning, then you can take quite a lot of that peak electricity demand again, and it's probably only something around 60% of the current electricity peak capacity we'd need to build again for full electrification of the whole of the heating system for every property in the UK. So that's a big challenge. There's still quite a lot of generation. There's still quite a lot of wind turbines and nuclear, or whatever your favourite electricity generating technology is. Still quite a lot more, but it doesn't seem an impossible task over the next 15 years to do that.
These predictions given at the summit were based solely, though, around the electrification of heat. Dr. Truella accepted that the likely increase in electricity demand for transport would also need to be factored in any future plans.
If we were to, in parallel, electrify transport completely, that would require its own uplift in generating capacity, and looking at the numbers, probably a larger one than that for heat. The good thing about electrification of heat and transport at the same time is that they can both be part of the solution to the grid balancing. So most vehicles sit for 90% of the time doing nothing, just standing still. And if they were plugged into the grid, they can A, be charged when it's most sensible, and B, actually even recharged back to the grid at certain times. So a smart centralised control of heat pumps and vehicle charging could dramatically reduce the amount of new electricity generating capacity that needs to be built. In fact, it could even go quite a long way with just taking up the periods of overcapacity that we have now. That would actually take you quite a long way in both those directions. But going forward, the amount of investment needed in new generation capacity would be way lower when you think of it all together.
And would that be the smart that again comes into?
Again, that's smart. Yeah, smart devices. I mean, the project that we mentioned earlier in Oxford actually is a three-pronged approach. Alongside the 300 heat pumps that are being fitted, there are 2 very large, in fact, I think the country's highest power vehicle charging station at the same time, and there is a large 50 megawatt hour battery being connected to the grid for balancing the grid directly and trading when electricity is cheap, selling it back to the grid when it's expensive. And so all of those 3 things are going to be modelled and run simultaneously. So in that area, it's pretty clear to see that doing the 3 things at the same time is completely the sensible way of doing it.
And is it possible to say who that trial project is?
Yeah, it's an Innovate UK funded project. So it's in the public domain. It's being led by a company called Pivot Power, who are the grid battery specialists, along with Oxford City Council, Oxford University, and a company called Habitat, who are writing the software to optimise everything, and a company called Red T, who are as part of it, trialling a flow battery. It's actually 48 megawatt hours of lithium and 2 megawatt hours of
and that will be
vanadium.
collecting data from, was it next winter?
From next September, September 20.
That was Dr. Matthew Truella of Kensa Contracting. Please join us for the second part of this podcast, where we'll consider the role that smart metering may play in expanding the cost and energy efficiency appeal of heat pumps. This will likely put pressure on appliance manufacturers to play a more significant role in the wider service of providing and controlling heat demand. We hope to see you then, and thank you for listening.